We can determine what a picture is going to look like based on the equation that we're given. For instance, let's look first at f of x is equal to 2x plus 1. Notice that this has a degree of 1, a highest exponent understood here to be 1. Whenever something has a degree of 1, the shape that we're going to get is going to be a line, and here you can see the picture drawn for us. Since this is in slope-intercept form and has a positive coefficient on the x, this is going to be a line that goes uphill or increases throughout its domain. Remember that domain is a fancy way of saying, tell me the things that are okay for x. We decided that the best way to find the domain was by looking at the equation and looking to see if there is a fraction that has x on bottom or if there is a square root. When you look at f of x equals 2x plus 1, there's no fraction and there's no square root. So the domain for this is all real numbers from negative infinity to positive infinity. Now, if there is a fancy word that means tell me what the x's are, there should also be a fancy word for the y values. While it's easiest to figure out what the domain is by looking at the equation, we can find our range, the fancy word for the y values. We can find it best by looking at the picture and looking for the lowest y to the highest y. When I look at the picture that we've drawn here, this one is going forever down on the left-hand side toward negative infinity. On the right-hand side, it's going forever up toward positive infinity. So the lowest y, there's not one. The highest y, there's not one. From negative infinity to positive infinity then would be our range. Let's look at someone else with a degree of 1. This one, negative 2x plus 1, notice that it's going downhill, decreasing throughout its domain. It's going downhill because of that negative coefficient that gives us a negative slope and makes the picture decrease throughout its domain. When you think about what the domain would be, look and see, is there a fraction or is there a square root? This equation, minus 2x plus 1, doesn't have either thing that is a problem for domain that we know of so far. So now let's say that the domain is from negative infinity to positive infinity. You can put in anything that you want for x. The range of this one might be a surprise to you. When we write our interval notation, we always want the smaller thing on the left, the larger thing on the right. So now, even though it's the right-hand side of the picture that's heading off toward negative infinity, when we look for the lowest y is negative infinity. The highest y is positive infinity. So the range this time, lowest y to highest y, negative infinity to positive infinity. Remember that infinities always have parentheses with them. Let's look at a different picture. Here I've got something with a degree of 2. Our equation is f of x equals x squared. That highest exponent, 2, gives us the degree of 2 and makes the shape into what is called a parabola. Anything that has a degree of 2 looks like a U. Things with a degree of 2 will always have this U shape, a parabola. Now, when you think about the domain, do we have a fraction here? We do not. Do we have a square root? While we have a square, there is not a square root. No fraction, no square root. That gives us a domain from negative infinity to positive infinity. Now, as you look at your picture to determine the range, the lowest y happens here when y is 0. There's not a highest y. Both sides are shooting up toward infinity. So the range of this thing is from 0 to infinity, the lowest y to the highest y, 0 to infinity. Here is another problem with a degree of 2. This time, the negative flips the picture across the x-axis. That is called a reflection. And so now our U is turned over, pointed down. It's still got that U shape because it has a degree of 2. When you look at this equation, is there a fraction or a square root? There's not. So our domain is again from negative infinity to positive infinity. Now, as you think about the range of this one, the lowest is going to be negative infinity because it's heading down forever on both sides here. So negative infinity is our lowest y. What's our highest y? It's up here at 0. So the range of this, it has a low value of negative infinity and a high value of 0. So lowest y to highest y, negative infinity to 0. Notice that the 0 is included here because 0 is actually a spot that is part of our graph. We give a bracket on the 0 to say that it is included. Infinities still get parentheses. Now, both of these pictures are even functions. Remember that we decided if something would be even or not by looking at the equation and looking for all even exponents or maybe an absolute value. Since these two pictures have all even exponents, that makes them even functions, and even functions have y-axis symmetry. That means I've got the same stuff on this side of the y-axis that I do on that side of the y-axis, and that points on each side of the y-axis will match up with each other, the same height as each other, the same distance from the y-axis. Let's look at the next picture. Here, these pictures have a degree of 3. When you have a degree of 3, the shape that you're going to get will be an S, something that looks like an S. Here, with a positive x cubed, it's down on the left, it's up on the right. When you look at that equation, is there a fraction or a square root? There's not. So our domain is from negative infinity to positive infinity. The lowest y, it's going down forever right here. So negative infinity is our low y. Positive infinity is our high y up here. So the range is negative infinity to positive infinity. Now, this particular function is an odd function because it's got all odd exponents with no constant value. Odd functions have origin symmetry. That means that the point -1 is part of the picture. +1 is part of the picture as well. If we make a negative out in front of this equation, the effect again is to flip the picture across the x-axis. So now nothing really changes here about our domain or range. It's still got no fraction and there is no square root, so negative infinity to positive infinity is our domain. The range, the low y is over here and it's heading down forever to negative infinity, while the high y is over here heading to positive infinity. Again, it's an odd function, all odd exponents, no constant value, so it has origin symmetry, O for odd, O for origin. The next shape that we have is an absolute value. Whenever you have an absolute value of anything, the shape that you'll get is going to be a V. Absolute value pictures look like a V. Our first one is just absolute value of x. When you look to determine what the domain is, do you have a fraction or a square root? You don't. So the domain is from negative infinity to positive infinity. The range of this, the lowest y is here at 0, and it goes forever up, so the range is from 0 to infinity. The bracket there with 0 says that there's a spot on our picture where the y value is actually 0. Now remember, this is our special case of being an even function with y-axis symmetry. As long as an absolute value has not been moved left or right, then it will have y-axis symmetry and be an even function. For instance, the one here, the +1 that's been put on the back moved the picture up by one place. This is called a translation. When we move the picture up by one place, that just changed what our range was going to be. The domain, there's still no fraction, there's still no square root, so the domain is still from -infinity to +infinity. But the range this time, the lowest y is at 1 this time, so our range begins at 1. It goes forever up. Both sides are pointed toward +infinity. So the range for this one, a low value of 1, a high of infinity, the range goes from 1 to infinity. This again is an even function with y-axis symmetry. Notice that both sides of the y-axis, you have parts of the picture matching up with each other, same height and same distance from the y-axis. Our next picture is a square root function. This is described as a gentle curve to infinity. As the picture moves from the left to the right, it's continuing to go up, but it's going out a whole lot faster than it's going up. Now, the first thing that we should notice here about this is that it does have a square root. So the stuff up under the radical has to be greater than or equal to 0. If we take x greater than or equal to 0, there's no work to do. It's just going to give us 0 to infinity for our domain. The range of this, the lowest y value that we have is 0. The highest, it continues to go up as we move out to infinity. So from 0 to infinity is our range. Notice again that the 0 is included because there's actually a place where 0 is the y value. One more for us here. This is the square root of x minus 1. Notice that the -1 is under the radical. So when I take the stuff up under the radical, make it greater than or equal to 0, that gives us a domain of from 1 to infinity. Move that 1 across by adding it, and you get 1 to infinity for our domain. The range of this one, the lowest y value that we have is at 0, and it goes forever up, so 0 to infinity is our range. Domain means tell me the x's, and we're looking for a fraction or a square root to restrict them. The range of a function is the lowest y to the highest y. And remember that infinities always get parentheses, but things that are included get a bracket. Depending on what the equation is, that tells us the shape that we can expect.